Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1857, largest color value in a directed graph. Okay, so let's read the problem statement first. There is a directed graph of n colored nodes and m edges. Okay, the nodes are numbered from 0 to n minus 1. Okay, so if you see this example number 1, so these are the colors given to us. So what is the total length? Total length is 5. Okay, n is equal to 5, right? So we have nodes from 0 to n minus 1, 0 to 4, right? 0 1 2 3 4. Okay, and edges are given to us, right? You are given a string colors where colors of I is the lowercase English letter representing the color of the ith node in the graph. Okay, you are also given a 2D array edges where edges of j, aj and bj indicates that there is a directed edge from node a of j to node b of j. Okay, so here 0 to 1 there is one edge, right? 0 to 1. Okay, 0 to there is an edge, 2 to 3 there is an edge, 3 to 4 there is an edge. Okay, a valid path in the graph is a sequence of nodes x1 to x2 to x3, right, until xk, such that there is a directed edge from x of I to x of I plus 1 for every I from 1 to k. The color value of the path is the number of nodes that are colored, the most frequently occurring color among that path. Okay, we have to return the largest color value of any valid path in the given graph, or -1 if the graph contains a cycle. Okay, -1 if the graph contains a cycle. Okay, we have to find out this one as well. Okay, so if cycle is there, return -1. Okay, and otherwise we are checking all the valid paths and we are checking the most frequently occurring color in that particular path, right? So here in this example number 1, if you see, this is one path, 3 to 4, this is one path. Okay, but this is also one path na, 2 to 4, this is also one valid path, right? This is also one valid path, right? 0 to 4, right? So starting from 0, because from 0 only we are moving to 2, right? From 2 only we are moving to 3, from 3 only we are moving to 4. Okay, so this is one valid path, 0 to 4, and this is second valid path, 0 to 1, right? Right, so here if you see, we are starting from 0 only, right? Every time in these two valid paths we are starting from 0 only. So this 0 is having in degree 0, right? There is no other value coming to this node. Okay, so in degree is 0 for this, right? Okay, so for this two, in degree is 1 because there is one node which is incoming to it, right? There is no incoming node for this node 0, right? So in degree is 0 for this one, right? So we are starting from this. Okay, and how we are treating this as valid path? So because here see, this u, this u, okay, let's say this is u value and this is v. Okay, so u is always coming before v, right? So here if you see, this is one valid path. Okay, 0 to 2, 2 to 3 and 3 to 4. All right, and if you see the colors here, so here this, if I just give the indexing here, 0 1 2 3 4. Okay, so 0 is having a color, 2, okay, having a color, this 3 is having a c color, and this 4 is having a color. Okay, so a is occurring 3 times in this path, right? So 3 is my output, right? Okay, and there is one more valid path, 0 to 1, right? 0 to 1. So in this path, 0 color is A and your 1 color is B. So both A and B are occurring just one time, right? A is occurring one time, B is occurring one time. So we have to return max. So max is 1 only. So in these two paths, okay, two paths are valid. So in these two paths, 3 is a max, right? So we are returning output 3. Okay, so path 0 2 3 4 contains 3 nodes that are colored A, red in the above image, right? Okay, so here first thing that we need to do here, first we have to find the valid path that we need to check. Okay, we have to find out the valid path. Okay, so 3 and 4 is also valid path, right? But in this problem we are taking this, this is also one valid path. Okay, u 2 3 4, but we are taking this 0 to 2, 2 to 3 and 3 to 4. Okay, so we are taking this valid path. Okay, so why we are doing this? Okay, so this is a valid path, right, that we are taking. Why? So this is nothing but topological sort. Okay, so topological sorting of a directed acyclic graph, DAG, okay, directed acyclic graph, is a linear ordering of its vertices such that for every directed edge 0 to u to v, vertex u always comes before v in the ordering. Okay, so vertex u always comes before V in the ordering, right? So it only works on DAGs, directed acyclic graphs. Okay, so what we are doing? We are doing topological sorting here, right? Okay, so we don't have to take this path 3 to 4. This is also valid path 2, 3 to 4. This is also valid path. So we have to take this only, right? Right. So here let's suppose in topological sorting, let's suppose this is node 0, okay, and this is a node 1, and this, let's suppose this is node 2, okay. So can I write like this 0, 1 and 2 in topological sorting? No, I can't write, because here if you see, one, this is u, let's say, and this is v, okay. So here this is valid, right? So u to v, okay, 0 and 1 only comes after 0, right? So this is valid. But here this one comes, this 2 comes after 1, no, right? So this is not valid, okay. 1, this 1 comes after 2, okay. So in topological sorting we have to write it like this, 0 2 1, okay. So now if you see, 1 is always coming after 0, and here you see 1 is always coming after 2 also, right? Okay, so this is valid, okay. This is not valid. So topological sorting of a directed acyclic graph DAG is a linear ordering of its vertices such that for every directed edge u to v, vertex u always comes before v in the ordering, okay. So it only works on DAG, directed acyclic graph, okay. So here what we are going to do, we are going to implement Kahn's algorithm, okay. That is nothing but BFS based topological sort, okay. So in this, what we do, we use in degree, that is number of incoming edges, to process the nodes. So what is the algorithm for this? So we compute in degree of all the nodes, right? So here in degree, number of incoming nodes for this one is just 0. Number of incoming nodes for this 2, 1. For this 3, 1. For this 4, 1. Okay, and this 1. Okay, only one incoming node. So we compute the in degree of all nodes. We are going to add all the nodes with in degree is equal to 0 to a queue. Okay, so we are going to create a queue, and in that we have to add the all the nodes with in degree 0. Then while the queue is not empty, we are going to remove a node u from the queue, and for each neighbor v of u, we are going to decrease the in degree of v, and if in degree of v is going to become 0, then we are going to add v to the queue, right? And if we can't process all nodes, then simply means there is a cycle, okay. So just understand this Kahn's algorithm, okay, and what is this topological sorting. And now after that, this I'm going to show you how we are going to implement these two things in our problem, okay. So here first let's understand, here let's say you have this node, okay. Okay, so here let's say this is 0, okay, and from this there is one node 1, let's say, okay, and from here there is one node, let's say 2, okay, and from here let's say there is another node 3, okay, and 3 is like this, let's say. All right, and here let's say the color of this is a, okay, color of this is a, right, and let's say color of this is c, okay, and let's say the color of this one is b. Okay, so first let's understand this thing. Let's suppose this is your u, okay, u to v, there is an edge, okay, in directed acyclic graph, okay. Let's say u and v. All right, so here let's say this color is a, and this color is, let's say, b, okay. So here let's suppose I'm writing the colors now. So a, we have colors from a to z, right? So let's say a is occurring 2 times here, okay, until 0, until this u node. Let's say a value is 2 only, right? B value, let's say it's nothing but 0. C value is nothing but let's say 0. D value, let's say, is nothing but 1, okay. So there are some paths previously, right? There are some paths from here, let's say, okay, and then u to v we are moving, right? So here until z we have colors, right? So let's say z is 0, okay. Now here tell me, if I move from this u to v, okay, for u I already know all the colors frequencies, like a is occurring 2 times, b is there 0 times, c is there 0 time, d is there 1 time, okay, until z, okay. I know all the colors, okay, until this u. Now from this u I am moving to v, okay. There is one path from u to v, okay. So here when I reach here, so I see that color is b, okay. So here color is b now, but here when I'm moving to u to v, so a frequency will remain 2 only, right? There will be no change, okay, because I am including this path now. I'm including this path, okay. So in this path a will remain 2 as it is, right? But b frequency, since this is b, so b frequency is going to increment. So previous b is 0, so in this 0 right now it is 1, so I'm going to add b frequency as 1, okay. And this c is going to remain 0 only, d is going to remain 1 only, right, and z is going to remain 0 only, okay. So here what I'm saying, that if I know all the colors okay, which are ending at this node, okay, all the colors which are ending at this node, if I know this, then definitely I can find this V, okay, right? So from U I can find V, okay. So here all the colors, all the colors, okay, all the colors which are ending at this particular U, okay. So here let's say colors, okay, all the colors like first A ending at U, if I know this value 2, right, all the colors ending at U, right, and let's say color is B, okay. So for this also we know the value. So if at U we know, that definitely we can find at V also, right? So we have to just do the addition of this, okay. So this is important thing. All right, and one more thing here, how I'm writing A is equal to 2. So let's suppose this is path 1, this is path 2, okay, this is path 3, and this is path 4, okay. So from this path, let's say A value is coming as 1, from this path A value is coming as 0, from this path A value is coming as 0, okay, and from this path let's say A value is also coming as 0 only, right? So here out of these paths, okay, out of all these 4 paths, let's say, so I have to pick the max one only, right? So in this path max values of A is coming as 1, and this is also 1, so I am doing here 2, okay. Instead of writing 0 plus 1, I am writing 2, okay. So here I am doing math.max, okay. So I have to do math.max as well, okay. So I hope that this thing is clear, right, what we are doing. So from how we calculate the answer from U, okay, for V, right? Now see this example, we are going to implement the same thing here, right? So we have to check all these colors now, A, B, C, D, okay, using all these colors, okay. So here after that again we are going to check all the colors, right? So we have to keep track of all the colors at all the nodes, right? Okay, we don't know the color of the next node, so we have to keep track of all the colors. So what I'm going to do, I'm going to create a one 2D array, right? So how I'm going to create that 2D array, so let's see that. So let's say this is your 2D array, right? So here let's say how many nodes we have? We have total 4 nodes, right? So here I'm going to write nodes, okay, 0, 1, all right, and here like this, right? So let's say this is 0, 0 to 1, okay, 1 to 2, 2 to 3, okay. So all this stuff we are going to check here, and here we are going to keep track of all the colors, right? So this is A, and then this is B, let's say, then this is C, let's say, okay, and so on until Z, okay. So we have to keep track of all the colors, right? And initially what I'm going to do, I'm going to fill all the values as 0, right? So here I'm going to write this as 0, this as 0, this as 0, this as 0, 0, 0, 0, 0, 0, and this one also 0, also 0, also 0, okay. So now this is done. So now first, using this Kahn algorithm, we have to calculate the in degree, okay, number of incoming edges to process nodes, okay. So we have to use in degree, right? So here for this A, if you see in degree is 0, okay. For this one in degree is 1, for this 2 in degree is 2, and for this 3 in degree is 0, right? So what you need to do, create one queue, okay. Let's suppose this is your queue. So in this queue you have to add the values with in degree 0. So let's say you have added this 0 and you have added this 3, okay. So now once you add this, then what you need to do, okay. So now we have to add this, okay, and here also at 0 you are adding now. What is the color at 0? A. So here just write here 1, okay. So here what I'm doing, how I'm writing this, so I'm writing the color count, okay. So here I'm writing color count, okay, color count, and here after this color count for the nodes which are ending at 0, okay, the color counts which are ending at 0 node, 0 node, okay, and having color this color, okay. So having color this A. So this is valid now, this is valid. So see here there are no incoming nodes, okay. So this is the only starting point, and for this starting point color is A, okay. So here I'm writing 1, okay, for this A. So same way we have to calculate for all now. So color count, okay, or ending at 0 for B, okay. So it is going to remain 0 only, no change, right, because this is the starting, okay. So here all are 0 only. Now same way for this 3 also you need to write, right, okay. So here what you need to do, so you have to add this in this your queue, okay, and then you have to write color count, okay. Here color count and color count for the node, okay, 3, right, for the nodes for the color count ending at this 3, okay. We have to keep track of the previous also, right, color counts ending at this 3 for this color B, okay. So this we are going to update with 1, right. So here just upgrade this to 1, all right. This is done, okay. Now once this is done, now after that we have to check the paths now. So here what are the paths? So first let's take 0. Okay, so take 0. Okay, so we are going to process it. Okay, so here increment, create one variable, processed nodes, and increment that. Okay, processed nodes and increment its value. Okay, so it was 0 initially, so now it is going to become 1. Okay, we are going to process this, and also create one variable answer. Okay, in the answer I'm going to keep track of the output. Okay, so initially answer is equal to 0, right? So now for this 0, what are the paths? So from this 0, okay, so let's take this as u. Okay, so u is nothing but 0. Okay, so so there are two paths now. I can move to this node 1 or I can move to this node 2. Okay, so first let's say from 0 I am moving to this 1 only, right? So this is my u and this is v. Okay, so now how I'm going to fill this, right? Okay, so this is what we need to do now. All right, so here first of all, just keep track of the answer. Okay, right now, so right now we are already process this now. So here this is my u. Okay, so add u. Okay, add u, and we are going to check all the colors. All right, so we are going to check all the colors here. We at u. Okay, ending at u, all the colors. We are going to check color count. Okay, this color count 0. This u. Okay, so this u is nothing but 0, let's say, and for all the colors 0 1. Okay, until z. Okay, so let's say 25. Okay, so we are going to check for all the values. So what is the max value until now here? What is the max value? Okay, max value is just 1, right? So we are going to update our answer as 1. Okay, since we have found this color now, only a right now, so answer is 1. Okay, right now answer is 1. Okay, so we have added this. Okay, so we are finding the max value. Okay, in this. Okay, ending at this u. Okay, max value 1. Now once this is done, now adjacent. So let's say we are moving to v. Okay, so now here we have to keep track of all the colors, right? So we are moving to this one, right? This one. So here if you see here, so 0 to 1 if you are moving, right? So that's in previously here. If you see at this point, at this node, okay, u color a frequency was 1. Okay, again we see that color of this one is again 1, right? So this is going to become 2, right? 1 plus 1 2, which is going to become 2, right? A frequency, right? A is occurring 2 times, 1 and 1 here. Okay, 0 to 1. Now same way here, b is going to remain 0 only. Now same way c is going to remain 0 only. Okay, z is also 0 0. Okay, this is going to remain 0 only. All right, okay, so here we have processed this, right? Now here if you see the integrity of this one, okay, this one is going to become 0. All right, we have already processed this, so integrity of this one is going to become 0 now. Okay, we have to decrement the integrity, right? So here if you see, where is that? Here, yeah, add all the nodes with integrity 0 to q. While the queue is not empty, remove a node u from the queue. For each neighbor v of u, we have to decrease the integrity. Okay, and if integrity becomes 0, then add v to the queue. So add 1 to the queue now. Okay, we have to add this. Now we have checked this path, right? All right, okay, now from this 0 also you can move to, we have checked this now, you can also move to 2, right? So here again check a, and here a value is coming as 1 from here. Okay, now this is my b. Okay, so here let me remove it, and this is my b. Okay, so this to this. Okay, so a is 1 and here it's 0, previous value is 0, right? Now a value is coming as 1. Okay, and this value is 0. All right, a value is coming as 1 and here it is c, not a. So here we have to write 1 only, right? Only a is coming, right? Same way here b is going to remain 0 only, and c is value, current value c now. So from upper side 0 value is coming, and now current value is 1. So here we have to write 1. All right, so we have to operate this to 1. All right, so now we have processed this c, and here this integrity is now decrementing to 1. Okay, it's not 0 yet. Okay, we have to decrease the integrity by 1, right? So here this integrity becomes 1. All right, so now this is done. Okay, so for this u and v, we have processed these two. Now after that we have to process this 3. Okay, so in order to process 3, okay, poll, and just here process nodes count increment to 2, right? And now for this 3, okay, so now here your u is going to become 3, your u is going to become 3, and now from 3 you can only move to what? You can only move to this 2, right? All right, only one path. Okay, so 3 to 2, right? So now see carefully. Okay, so add this 3 if you see. Okay, add this 3 if you see, the frequency of a is 0, right? Frequency of a is 0, but here frequency of a is 0 at 3, but here we are moving to this, right? 3 to uh 3 to 2. Okay, we are moving to this. Okay, 3 to 2, right? So here this frequency is just 1, right? So here 0 plus 1, so it is going to 0, and here this is values c, right? So from B to C you are moving, right? So here frequency of A is 0, and here also frequency of A is 0 only, but we have to keep track of the max one, right? Here previous max is 1, so here we are doing the math dot max, math dot max of, right? So here if 0, and here at 2 also it is C only, okay? Here it is 0 initially, and here also if you see, if you move to this 2, okay, it is C not A, so it is 0 only. 0 plus 0 0, but initially if you see I filled here 1, okay? So why this 1? So 1 is coming from this path, 0 to 2, okay? So we have to maintain the max only. So here I'm going to write it 1 only, okay? I'm not going to operate it. This is done. All right, so now this is done. Same way for B. So from here B value is 1, and here it's not there, so we have to update it to 1, okay? So this I'm going to update to 1. Okay, now here next time C. So from here it's coming as 0, okay, and this was also there, okay, as 1, okay? So here 0 plus 1, okay, C is there, and old value is also 1. So out of these two, max is 1 only, so I'm going to keep track of max only, okay, 1 only, right? So this is done. So we have processed this 3 also, right? So now this in degree of C is going to become 0. Now we have to add this 2 here, okay? And same way here also you have to keep track of all the values, right? So U is 3 now, so for 3 also what is the max value here? 1 only, so answer is still 1. Okay, now you have to process this one. Okay, 1 is coming out here. Here process node is going to become 3, and now for this one also here check all the colors which are ending at this node. Okay, so node 0, okay, node 0 is right now is 1, okay, and 1 there is no other thing, okay? But here if you see all the colors we have checked, so max is 2, so answer you are going to operate to 2 here, okay? And then after that we have to process this 2, and the process node is going to become 4. So here this U is going to become 2, at 2 again 1 only, but 2 is the max. We have to keep track of the max one already, okay? So here also after this 2 you can't move anywhere, right? There are no out degrees from here, okay? So that's it. So in the end your max value of answer is 2, and if you see we have processed all the nodes, so this is not a cycle, and then you have to return the answer value, okay? So this is what you need to do. Very simple problem, right? So let's write the code, okay? Same story, okay? Whatever I explained, we are going to have to do the same thing, right? Let's write the code now. So first thing here, what you need to do, just calculate the length of this string colors. Int n is equal to colors dot length, and once this is done, then we have to create the adjacency array list. Okay, so list of integer adj is equal to new array list, and then we have to check the in degree also. Okay, so int in degree is equal to new int, and here n, right? And then we have to initialize the adjacency list. So for that just run one loop for int I is equal to 0, I is less than n, I plus plus, and here after that here adjacency dot add, okay, new array list. All right, so we have initialized this. Okay, now after that we have to build the graph and in degree, right? So for that just iterate over all the edges one by one. You can use for each loop for that. Okay, here int edge in the edges, and here inside this you have to check u value. So u value is present at edge of 0, and v value is at edge of 1. All right, so this is done, and now here you have to write adjacency dot get u. Okay, in this u you have to add the value of v. Okay, u to v, that's a path, right? So here you have to add v. All right, and here you have to calculate the in degree. Okay, so in degree of v plus plus, right? So this is what how you calculate the in degree, build graph and in degree. Now we have to calculate the color frequency table for each node. Okay, 26 letters are there, right? So here int, and here color count is equal to new int and number of nodes we have, and we have to check all the colors, right? And I have already told you why we are checking all the colors, right? So 26, and then here we have to use q also. Okay, so q integer q is equal to new linked list. All right, and then we have to add the nodes with 0 in degree to the q, right? So here you have to run one for loop for int I is equal to 0, I is less than n, here I plus plus, and here after this, here just check if in degree value, okay, of this I, if it is equal to 0, then you have to add this to the queue. So queue dot offer, and here you have to add what? You have to add the I. All right, and then after that you have to update the color count to 1. Okay, so color count, okay, I, and here check the color at this particular position. Okay, so colors dot char at I minus, and here you have to write a, okay, and here you are going to just update it to 1. All right, so this is done. All right, simple code, right? So once this is done, then after that just take variable answer, okay, and set it to 0. Answer is equal to 0, and here we have to check the process node also. Okay, so processed nodes is equal to 0, and then here you have to run simple while loop. Okay, simple code while queue is not empty. Okay, while your queue is not empty, and here inside this take current, okay, u is equal to queue dot poll, and you have to increment the processed nodes count as well. So here processed nodes plus plus. Now once this is done, then you have to update the answer with the max color frequency at node 0. Okay, so here you can use one for loop. Okay, int c is equal to, we are going to check all the colors, right? C is less than 25 and c plus plus, and here answer is equal to math dot max of answer, and here you have to write color count. Okay, so color count, okay, total color counts ending at this 0, right? And for this particular colors, okay, a b c d until z we have to check, right? So we have to add the max value here only for answer, right? And then we have to check the neighbors also. So here int v is equal to adjacency dot get u, right? Now inside this just run one for loop. Okay, we have to keep track of all the colors, right? So here int c is equal to 0, c is less than 25, and here you write c plus plus. Okay, and now inside this you have to check, okay, if you want to add this color or not. Okay, so how, when you are going to add? So we are going to add only when colors dot char at this particular index, okay, this particular v value. Okay, so if this color, okay, minus a, okay, if this value is equal to c, okay, only in that case you have to add 1. Okay, otherwise you have to just 0, right? Say 0, right? Now here how we are going to add the color? Okay, so color count, okay, ending at this v. Okay, we have to check all the colors one by one. Okay, so here how you are going to update? So I have told you we have to use math.max. Okay, there may be different many paths, right? So here color count, okay, and this also, right? So here if you see we were not updating, okay, this was 1. Okay, so here I was writing 0 plus 0, so we are not updating, we have to keep track of max. Okay, 1 here, so 0 to 2, so here a was coming as 1, right? So from, if you start, if you see this 3 to 2, then you are not seeing any 1, right? So this is one valid path and this is one valid path, okay, ending at 2, right? So at 2 you see a was coming as 1 here from here, but from here if you see there is no a, right? We have to keep track of max 1 only, right? So that is why here I'm writing like this. Okay, so math.max color count v and c here, and old, okay, so old also we have to write, so here color count, now new one. Okay, so u and c, and in this we have to add this. Okay, done. Very simple, right? This is done. Okay, so now once this is done, then after that here you have to decrement the in degree. Okay, so in degree of v minus minus, and here just check if in degree is going to become 0. Okay, in degree of v, if it is equal to 0, then in that case you have to simply add this in the queue. Okay, so queue dot offer, and here you have to add v, right? This is done, and this is done here. Okay, now after this, if not all the nodes are processed, there is a cycle. Okay, so in that case we have to just return processed nodes value. Okay, if it is less than n, okay, in that case you have to simply return -1. Okay, and otherwise you have to just return answer. All right, so this is done. All right, okay, so now let's run the code and see if the code issue. Will try to fix that. So, okay, so there is one missing a return statement, so let's fix that. Okay, right, this is where while loop ends. Okay, so let's write it outside. All right, this here, let's write it, and here let's write it like this. Now let's run it. So see, all the test cases has been accepted, right? So now let's submit it. Okay, so there is some issue, so let's try to fix that. Why I'm writing here less than 25? It should be 26, right? So that is why that test case is getting failed. Okay, less than 26. 0, 25 we have now. 8, 26. Anything else? Let's submit it again. So see, all the test cases has been accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.